Good morning or afternoon, everybody, and thank you for joining us on D-Link's 10 Gig Ethernet Technology and Introductory webinar. I'm Carrie Mertz, Field Marketing Programs Manager for D-Link's Solution Provider Channel, and I have Steve Olin, Director of Product Marketing for Business Networking, here with us today to present. Welcome, Steve.
Thank you, Carrie.
Before getting started with the presentation, I would like to review a couple of important items. We're recording this webinar and it will be available tomorrow for viewing. There'll be a link to the presentation included in the follow-up email, and if you are a D-Link reseller partner, you will also find it in the partner portal, partners.dlink.com. All of the attendees' lines are muted. If you have a question for Steve, you can enter it in any time during the webinar in the Q&A panel, and we'll be addressing all questions at the end of the webinar. And if for some reason we're not able to get to your question during the webinar, we'll definitely follow up with you to make sure you get your questions answered. Also, we'll be giving away some D-Link product today to 2 lucky attendees. So we'll do that drawing at the end of the webinar as soon as Steve's done with his presentation, right before Q&A, to give Steve a little bit of a break. We will draw 2 lucky winners randomly and announce those winners for our D-Link product giveaway. And with that, I'll hand it over to Steve to get us going. Take it away, Steve.
Okay, thank you, Carrie. Hopefully everybody can see my screen. Again, I'm Steve Olin. I'm product marketing with D-Link. I'm primarily responsible for the business networking products, including switching and wireless. And today we're going to take a pretty comprehensive look at 10 gigabit Ethernet. The intention of today's discussion is to do a fairly broad brush across 10 gigabit Ethernet. I'm not going to do a deep dive into any particular topic, or we're not going to get too technical. I'm not going to be talking about amplitude modulation and things like that. Rather, I want to touch as many topics as I can within the general category of 10 gig Ethernet. So we'll talk about 10 gigabit on copper, 10 gigabit about fiber. We'll talk a little bit about different fiber types, make sure that we're aware of the different types like single mode and multi-mode. Here's the agenda. So we'll start off by looking at the 10 gig market, some of the market trends, the growth of 10 gig Ethernet over the last few years, and looking forward, where is the market going. Then we'll get into the meat of the presentation, talk about 10 gig technology, review the IEEE standards for 10 gigabit Ethernet, and then I've got some slides that show 10 gigabit real-world applications in the business environment. In our business environment, keep in mind here at D-Link, we primarily sell networking equipment into businesses of all sizes, school systems, retail, government buildings. So that's really the perspective that I'm going to give here is in our industry how 10 gigabit Ethernet is used. And then I've got a couple of slides at the end that review some of D-Link's 10 gig switches and accessories. So let's get started and take a look at the market. Start off by talking about what's really driving the need for 10 gigabit Ethernet. And to me, the answer is pretty clear. It's bandwidth. It's just the need for more bandwidth. There's an increasing amount of data in business networks today that needs to be processed, stored, backed up, and accessible. And so business networks need fatter pipes. They need more bandwidth. We've got servers that are becoming faster and faster, and so the network infrastructure, the bandwidth, needs to keep up. In a lot of cases, gigabit used to be acceptable. It used to be enough. Now it's not. Now we need 10 gig. With server virtualization that you've probably heard about, virtualization is taking one server and partitioning it into several virtual machines, and the number of virtual machines per server continues to increase. In the days of old, you would look at a server and find 8 gigabit ports on the back. Today's servers have 1 or 2 10 gig ports. It's more economical. It's less cabling required, and it actually increases the bandwidth. So we're seeing more and more 10 gig connections on servers, on storage. Networks are getting simpler. Traffic is converging. Fiber channel over Ethernet is a good example of storage traffic now running on Ethernet network. And probably the most important bullet, 10 gig prices continue to come down. And I've got some detailed slides on that. We'll look at that in a little bit. that show what's happening and projections for 10 gig costs. So all of these factors together continue to drive more and more 10 gig every year in business networks. Let's look at some industry data. IDC put out a press release a while back that I grabbed some quotes from. They looked at 10 gig Ethernet switching revenue last year, and they showed that the revenue, and this is worldwide data by the way, revenue increased a little over 5% year over year. Meanwhile, port shipments grew almost 25% year over year. So when I see disparity here, I see port shipments 25%, revenue growing just 5%. It leads me to believe that we have price erosion. Prices are coming down, and that's certainly true. Nevertheless, the market continues to grow. Look at some Infinetics data that we had. The particular quarter that they were looking at, they said revenue on 10 gig Ethernet was slowing, but port shipments had grown 27%, driven by the things we talked about: data center upgrades, server virtualization, core network build-outs. Maybe better to look at the hard numbers here. Let's look at some pictures. I like this one. This again is from Infinetics. It shows from 2012 historical all the way up through projecting into 2018. What you're looking at here is port shipments on a worldwide basis, and the different columns are the different speeds. So the blue column on the left is 100 meg, and stands to reason 100 meg still ships today, but as you look from year to year to year, the trend is downward for 100 meg. Meanwhile, the maroon column is gigabit Ethernet, and gigabit continues to grow, and that also makes sense as there's more and more ports deployed, and still a lot of them are gigabit. But what's interesting here is the green column. So the green is 10 gig, and that's our discussion today. And you see from 2012 to 2018 a positive upward trend on port shipments for 10 gig. Maybe not rivaling that of gigabit, but growing, clearly growing stronger every year. And then the other two columns, the purple and the blue, are 40 gig and 100 gig, and worth paying attention to, but a little bit beyond the scope of today's presentation. Now, instead of looking at ports, this graph looks at switch revenues. And again, this is a worldwide market forecast perspective. So the column on the left, the blue column, is 100 meg, and you can see it's almost down in the noise as far as revenue contribution. And again, that makes sense. A lot less 10100 being shipped every year, although here at D-Link we still do a fair share of 10100, especially in our switching. But gigabit is king. That's the red column here, and you can see 2012, 2013, 2014, that was predominant. But look what's happening as far as revenue contribution goes. Here in 2015 and going into 2016, the gigabit is trending down, and what's trending upwards is the green column, and that's 10 gig. So we actually have a crossover point happening here in 2015, where from a revenue perspective, 10 gig is overtaking gigabit. And then again, 40 gig and 100 gig, certainly not something we want to ignore, but they're kind of down in the noise at this point, but maybe in a year or two, that's something we'll be talking about a little bit more. And then the last slide, maybe the most important one here, is taking that data and looking at it from a cost per port perspective. The blue line at the bottom is 100 meg, and again, it's really kind of down in the noise as far as cost per port. And it continues to go down, by the way, as does gigabit. So gigabit is the red line, and you can see a downward trend as technology progresses and ship more and more product, costs per port go down. But what's most notable here is the green line, and that's 10 gig. So I look back 3 years ago, and it was pretty common to see 10 gig switches selling at an average of over $300 per port. And if you can see the downward trend here today in 2015, we're rapidly approaching $100 per port, and as we look out a couple of years from now, 10 gig costs continue to go down at a pretty substantial rate here. In fact, we'll talk a little bit later about some of our 10 gig smart switches that we introduced earlier this year. And we've already broken that $100 per port price barrier on our 10 gig smart switches. So bottom line, costs coming down, 10 gig demand going up, and 10 gig revenues are actually overtaking gigabit revenues this year in the industry. So now let's shift gears and go and talk a little bit about 10 gig technology. We'll review the IEEE standards. And I want to start off by showing a lot of different 10 gig protocols. There's 10 gig Ethernet, of course, but sometimes we hear about 10 gig fiber channel, 10 gig SONET, which is also called OC192, and it's widely used still in the telecommunications service provider industry, and also is OTN, which is ITU standard, ITU G.709. What I want to point out today is that we're talking about Ethernet. We're not talking about these other protocols. We're not talking about fiber channel and SONET and OTN. Today's discussion is just about 10 gig Ethernet. The IEEE standards that define 10 gig Ethernet are shown on the right side of the slide here, and we'll get into all of them. They discuss 10 gig Ethernet over fiber and over copper, and I've got slides on all of this. So I just want to stress we're talking about Ethernet today, not the other 10 gig protocols that are sometimes used in other industries. And when we talk about 10 gig Ethernet, we want to make sure we understand the IEEE standards define it as only full duplex point-to-point links. So you recall back in the days of 10 meg and 100 meg Ethernet where you could have hubs and you could have a whole bunch of different devices on one LAN cable, and sometimes there's collisions, so there's protocols like CSMA, CD, which is carrier sense multiple access collision detection, and that was all acceptable back in the days of 10 meg and 100 meg, but here with 10 gig Ethernet, no more half duplex, no more hubs. The standard specifies it has to be full duplex point-to-point links. And before I go a lot further on 10 gig, I want to pause a little bit here and talk about fiber optics, because I know a lot of people on today's webinar are a little bit new to some of this discussion, and they may need a little bit of a review on fiber. So I just want to define some concepts and define some terms here, because we're going to be talking about 10 gig over fiber. So optical fiber, fiber optics, that's basically just sending signals from one location to another in the form of a modulated light wave. And it's guided through a hair-thin glass fiber. That's fiber optic. And when we talk about the actual fiber cable, there's different components, and you look at the picture here, the core is the center of the fiber, and that's the actual glass fiber, the core, and the light wave travels down that core. And the core is surrounded by something called cladding. And the cladding is actually what traps the light in the core and kind of guides it down the path. And then on the outside, we've got buffer, we've got jacketing, and that will vary depending on the type of fiber and where it's being used. Obviously, a fiber run that's outside, up on a phone pole, is going to have a lot of jacketing and a lot of protection on the outside to protect it from damage, protect it from moisture. So I just want to make sure I define those terms. Core is something that I'm going to be talking about a little bit later. I'm also going to be talking about wavelength. Wavelength is a property of the light wave. If you think about a sine wave and you measure the peak-to-peak distance from the first peak to the second peak, that's the wavelength. Visible light, the light that we can see with our eyes, for example, is typically around 400 nanometers to 700 nanometers in wavelength. So with fiber optic communications, we're normally using wavelengths from about 850 nanometers up to about 1550 nanometers. And we use these wavelengths because they're a little bit longer, and they actually do a better job traveling through a medium like glass. The symbol that's on the right side, that's the Greek letter lambda. Quite often you'll see wavelength referred to as the lambda. The lambda is 850 nanometers, for example. Another thing that's talked about a lot in the world of fiber optics is attenuation. Attenuation is basically the loss of optical power. It's measured in dB per length of cable, and attenuation is caused by absorption and it's caused by scattering. So absorption is basically absorption of the light into impurities in the glass, and you can see absorption is shown here on this diagram by the purple dotted line. You see those two peaks there. There's a lot of different fibers that are manufactured that minimize absorption. I'm showing a general, the properties for a general piece of fiber cable here, but those absorption peaks typically occur around 1,000 nanometers, around 1,400 nanometers, and then out beyond 1,600 nanometers. So those are typically wavelengths that are avoided. And then the other cause for attenuation or loss of optical power is scattering. And scattering is shown by the blue dashed line that kind of comes sweeping down from the left. And so you can tell that scattering is inversely proportional to wavelength. Excuse me. And so you certainly get more losses due to scattering in the lower wavelengths like 850 than you do up around 1550. So if we want to go longer distances, we're typically going to use a wavelength like 1550 because we have less loss due to scattering. So the green line here is actually the total. If I add the two together, the green line shows me a typical attenuation over fiber based on or subject to the different wavelengths here. Optical loss budget is another term that comes up, and that's basically the amount of power that's allowed to be lost on an optical link. So I'm transmitting an optical signal at a certain strength. I know what that strength is. I'll typically measure my fiber and understand its optical loss budget, and as long as that's less than the transmit power of my my fiber optic transmitting devices, then I know I'll get a good optical link. Okay, enough about the technical stuff. Why would I do communication over fiber versus copper? A lot of reasons. Probably most people point to bandwidth first. In general, you can always get more bandwidth over over fiber optics than you can over copper. Now today we're going to talk about 10 gig, which is doable over both fiber and copper. But when we get up into the even higher speeds, usually fiber is the way to go. Fiber is immune to EMI, electromagnetic interference, so I can take a fiber cable and I can run it on phone poles outside right up near the high voltage wires, and I don't have the same kind of concerns that I would have if that was copper wire as far as susceptibility to EMI. Fiber is going to have much lower attenuation, so in other words, it can go longer distances than copper. That's why telephone companies and cable companies use fiber outside to go from town to town or city to city or state to state. And fiber is not electrical, so I don't have the same concerns when it comes to grounding and lightning outside and crosstalk issues that quite often I do have to be concerned with copper cabling. And then let's get into the two different fiber types. Some of you, I'm sure, are familiar with multimode and single mode. Some of you may not be, so I'll review them quickly here. Multimode fiber is a little bit lower cost than single mode. And in our industry, again, D-Link's industry, we're providing network equipment into business networks, school systems, retail, government buildings, is usually the fiber type that's deployed. It doesn't go the same distances as single mode, but in a business building, multimode is typically sufficient. So you can save money by going with multimode. There's a lot of different types of multimode cable out there. I call the first version of multimode, I call it legacy multimode fiber cable that was deployed, I guess probably way back in the 70s when fiber was first coming out. Some people call it FDDI grade multimode fiber. It wasn't very good quality, but it's still in some buildings today, buildings that were built back during that time frame. But over the years, multimode fiber has improved in its quality. We started with OM1, OM2. Today, most folks are deploying either OM3 or OM4 fiber cabling, which has a 50 micrometer diameter core on the inside. Multimode is nice because your optics can use LEDs or VCSELs. VCSELs are vertical cavity surface emitting lasers. In essence, they're lower cost, so you can save money on multimode because your optics are lower cost. But again, multimode, shorter distances. In a business building, going from floor to floor or one end to the other end, it's typically sufficient, so you can save money versus single mode. And you can see in the lower right picture here, symbolizing light waves going through that fairly large core. They kind of bounce around a lot, and because of all that bouncing around, we're not going to get the same kind of distance as we would over single mode. So now this slide is showing single mode fiber, typically going to be yellow. If you see a yellow piece of fiber, in all likelihood it's single mode. Single mode has a narrower core. It's 9 micrometers, but it requires higher cost lasers to transmit that optical signal down the fiber. Subsequently, it's better for longer distances. And phone companies, cable companies are going to use single mode fiber to go those distances. And even in a business environment, sometimes single mode fiber would be required, especially for a campus application where we're going across the campus from one building to another, or we've got outside plant, OSP is outside plant, where we have distances to be concerned with. And you can see in the picture on the lower right here, trying to symbolize a light wave going through a single mode fiber because the core is much more narrow. There's not as much bouncing around of the light wave inside. Of course, everything here I'm showing is very simplified. If we were to get extremely technical, there's a lot more to it than that. We'll look at connectors very quickly here. Fiber optic connectors. 10 years ago, SCs and STs were probably the two most popular connector types. Today, in our industry, I see mostly LCs. I still see some SCs, but LCs have become very popular. Largely because of the SFPs, the transceivers that we're going to talk about on an upcoming slide. Most SFPs and SFP plus transceivers today have LC connectors on them. So we see a lot of LC connectors. Certainly there are others. A lot of people used to like FCs, and MTRJs were in favor for a while. MPOs are still in use today for even higher speeds. MPOs are multiple fibers in a connector, but primarily, again, when we're talking about 10 gig, most of the transceivers and the devices that we're going to see use the LC connector. So let's get into the IEEE standards now. First, we'll talk about 10 gigabit over multimode, and the IEEE released that standard 802.3AE back in 2002, and we call it 10G base SR. I think of SR as short reach or short range. I'm not sure if that's officially what it stands for, but that's a mnemonic that I use. So again, 10G base SR is over multimode fiber, 10 gigabit speeds using the 850 nanometer wavelength. It's typically going to use the VCSELs, which are low cost, but low power as well. And at the bottom of this slide, I'm showing over the various types of fiber, what kind of distances you would expect with 10 gigabit Ethernet communications. So on the low end, this old legacy FDDI grade fiber that was installed a long time ago, not very impressive, maybe 26 meters. But with today's fiber, the OM3 and the OM4 that's normally being deployed, 300 meters for 10 gigabit over OM3, 400 meters over OM4. And that is normally going to be sufficient to get 10 gigabit signals from one floor to another in a business building or one side of the building to the other. So what I've circled here in red is the OM3. That's predominantly what's still being deployed today. It's very low cost, it's easy to deploy, and you can get reasonable distance with 10 gig speeds. Now we'll look at single mode. So the IEEE had 802.3AE, which addressed 10G base LR and 10G base ER. I think of LR as long range, long reach, ER as extended range, extended reach. So with 10G base LR, we're using a 1310 wavelength, a little bit of a longer wavelength, but we get longer distance out of that as well, up to 10 kilometers over single mode fiber. And 10G base ER uses more power, and it uses a 1550 nanometer wavelength to get up to 40 kilometers, which is almost 25 miles. So again, very good for service providers, phone companies, cable companies that are going from town to town, city to city, but also good for business networks if we're going through a campus and we are going beyond, we want to go 10 gigabit beyond the 300 or 400 meters that I get with multimode. Typically, what I'm circling here is the 10 kilometers, or a little over 6 miles, is what's normally deployed in our industry, in our space, when our customers are doing campus type of applications. The last one I want to talk about is LRM, 10G base LRM. I think the industry realized that there's a lot of this old legacy multimode fiber installed, TDI grade fiber installed in old buildings, and recognizing that, remember on the previous slide I showed 26 meters was the best we could do with 10 gigabit speeds. So they developed 10G-based LRM, and what LRM does is it uses, instead of 850 nanometers, it's using the 1310 wavelength, and it's using techniques like electronic dispersion compensation. These are special techniques that allow the signal to go farther through this older multimode fiber. So here in the chart shown down below, on the legacy fiber, instead of 26 meters, we're getting 220 meters. So LRM is actually a good technology to choose for an older building where we don't want to swap out the fiber. We want to try to get 10 gig speeds over the existing old school fiber. And we actually here at D-Link, we sell a lot of optics still that use the 10G based LRM techniques. So there's a legacy 220. Okay, so that's a lot. I put it together a summary table in case this is something that you wanted to go back and reference a little bit later. 10G base SR is multi-mode, 300 feet over OM3, 400 feet over OM4 using the 850 nanometer wavelength. 10G base LRM for older fiber, older multi-mode fiber, wavelength of 1310, we can get 220 meters, 722 feet. And then 10G base LR is on single mode, 10G base ER is on single mode, and 10 kilometers to 40 kilometers respectively. All right, I want to talk a little bit about transceivers next. And I want to start with a little bit of history. You see a picture here of an older Ethernet switch that had fixed optical connectors. So this is a 24-port Ethernet switch from quite some time ago, and it was 24 fiber ports, and those look to me to be duplex SC connectors. So this is probably 100 megabits, could have been gigabit, but the problem is these are fixed optical connectors. I can't change them. If those 24 ports are multi-mode, I'm stuck with multi-mode. If they're single mode, I'm stuck with single mode. If they're gigabit, I can't change them to 100 megabit. So they're fixed, and switches of this nature today are relatively obsolete. And you've seen the industry has gone with modular connectors or modular transceivers, and we call these SFPs. And I'm sure you've seen SFPs quite frequently. SFP stands for small form pluggable. There's a picture of one here with the arrow that says transceiver. Basically taking a light signal and converting it into electrical signal so it can interface with the switch itself. The nice thing about SFPs is they're modular, and I can swap them out, I can change them. So if I want multi-mode in port 1, I use a multi-mode SFP. If I want single mode in port 2, I use a single mode SFP. If I want gigabit in port 1, I use gigabit. If I want port 9 to have a 100 meg, I can put a 100 meg SFP in there. So it's much more modular, gives me a lot more flexibility in how I set up my switch. So that's what a transceiver is. You also hear them talked about as SFPs. Now, when 10 gig came out, the first 10 gig transceivers were what you see here. They were called Zen packs. They were competing very similar form factors like X-Pack and X2. Quite big, quite bulky. The one shown here has duplex SC connectors. They consumed a lot of power. They generated a lot of power, or a lot of heat, excuse me. But these were the first transceivers that came out for 10 gig Ethernet. Not really shipping a lot of Zen packs anymore today in 2015. They were replaced by a smaller form factor that we called XFP. XFPs available in many different wavelengths for 10 gigabit. Typically LC connector. I chose a bad picture here because there's a rubber dust plug obscuring the LC connectors, but that's what you'll find on XFPs. Still in use today, especially for wave division multiplexing applications. WDM is something that's beyond the scope of today's discussion, but it's using very precise wavelengths to actually multiplex multiple wavelengths over a fiber, a single fiber or a fiber pair. So XFPs still in use today, especially for those more specific applications. We still sell some XFP transceivers here at D-Link because a couple of our older legacy switches use XFP for their 10 gig optics. But in general, the industry has gone to SFP pluses. So SFPs came out with 100 meg and gigabit, and now with 10 gig, they're called SFP plus. The plus is enhanced, small form pluggable, certainly smaller than the XFP. LC is the connector style, and also available in many different wavelengths. So SFP pluses for 10 gig, available at 850 nanometers, 1310, 1550, and also for wave division multiplexing. SFP pluses, these transceivers continue to come down in cost and make 10 gig Ethernet more and more affordable every day. So we just did a lot of discussion about 10 gig over fiber. I'm going to now talk a little bit about 10 gig over copper because there's several different ways I can do that. And the first one I want to talk about is CX4. So this was actually one of the IEEE standards, 802.3 AK, back in 2004. And you can see a picture here of a CX4 connector and a CX4 cable. It was the, let's see, 15 meters is the, I believe, the maximum distance for CX4 technology. So that means it's typically going to be used within a rack or maybe from rack to rack, but 15 meters doesn't really get you too far. The nice thing about CX4 is it supports the full 10 gig speeds. It's low power, pretty low latency, but it is kind of bulky cable, bulky connector. It's a good technology. It's still used today. We have a family of switches, the DGS3120 gigabit switches that have 10 gig stacking ports on the backside. We still sell a lot of 3120s, and these use CX4 for the stacking ports. You can see a picture of that here. So reasonably large install base. I think CX4 is a good technology, but it's slowly being replaced by 10G base T. So 10G base T, a little bit of a newer standard, although this has been out for upwards of 10 years as well. 10G base T is using a much more familiar connector. There's a RJ45 that we're used to with 10100, 1000 Ethernet. So same RJ45. Now with 10G base T, we can do 10 gigabits up to 100 meters, which is the distance that we typically think about when we think about Ethernet over copper. The one restriction here is it needs to be, per the standard, it needs to be Cat 6A, Cat 7, or better cabling. So I believe the standard does address 10G base T over Cat 6, and I think it allows for a limited distance. I've seen different vendors talk about distances from 30 meters to 55 meters. But I know when you're working with Cat 6 and 10G base T, we have to be a little bit more concerned about the quality of the installation, the routing of the cables, the bundling of the cables, what kind of crosstalk we're going to get from cable to cable. So in my mind, if we're working with 10G base T, it's a lot safer to ensure that we have Cat 6A or better cabling. That way we know we get the full 10 gig speeds up to the maximum allowed distance, which is 100 meters. 10G base T is also backward compatible with 1 gig. So if I have a 10G base T switch, I can plug 10 gig devices into it. I can also plug 1 gigabit devices into it. More on 10G base T. I'm not even sure I'd call it a maturing technology anymore. I think at this point it is a mature technology, and it's ready for prime time. 2, 3, maybe 4 years ago, the silicon vendors came out with new PHY chips. This is the silicon that actually does the 10 gigabit copper. Lower size, lower cost, lower power consumption, therefore less heat generation, and 10G base T at that point in time really became, as I say in the note below, ready for prime time. So today we see switches with 10G base T, and they're low cost, they're pretty low power. We see servers and PCs that may have 10G base T on the motherboard, directly integrated on the motherboard, which would be LAN on motherboard, and a lot of NIC cards as well, network adapters that are available to provide that 10 gig connectivity for servers and PCs. And I've got some examples of those coming on a future slide. So the point here, 10G base T, 10 gig over copper with Cat 6A, Cat 7, it's definitely something that is making 10 gig more and more of a reality for business networks of all sizes. I don't want to discount another 10 gig over copper technology called direct attach. A lot of people call these cables direct attach copper or DAC cables. This is basically a twin-ax copper cable, and if you look at that cable, there are connectors at each end that are SFP plus style connectors. And so what you do with direct attach copper is you plug these into your SFP plus switch ports or your server ports or your storage ports. And this is a very low-cost way to get 10 gig connectivity without having to spend money on fiber. So recognizing that multi-mode fiber costs money, the SFP plus transceivers, one for each end of the switch, will cost money. Terminating your fiber, splicing connectors costs money. If you're going short distances up to roughly 7 meters, you can forego the multi-mode fiber and use direct attach copper. So we see a lot of direct attach being used, especially within a rack, from switch to switch or switch to storage, or even from rack to rack, as long as the distance is limited to 7 meters. So here's a summary of the different media that we talked about here, or at least the ones that are most appropriate for business networks. The first one we talked about, multi-mode fiber, 10G base SR, very low power consumption, latency is very, very low. Cost, I would say, used to be high. Now, because optics cost is coming down, I'd say the cost for multi-mode solution is kind of medium. Maximum reach, 400 meters over OM4, and because it's optics, there's virtually no crosstalk issues that we have to worry about. With direct attach that we talked about on the previous slide, it's twin-ax copper, again, low power consumption, low latency. The cost is pretty low, but we're limited on distance, so 7 meters maximum with direct attach, and not a lot of concerns with crosstalk. I say low on crosstalk. I didn't put CX4 in here because of the distance limitations and the fact that CX4 is slowly falling out of favor. So I'm showing here 10G base T, which, as we talked about, Cat 6A, Cat 7 copper, we get the full 100 meters that we're accustomed to with Ethernet. A little bit higher power consumption. Right now we're looking at typically between 3 to 5 watts per port. For 10G base T, latency is a little bit higher, but for applications where we can live with that kind of latency, 10G base T is a really nice solution, a really low-cost solution for providing 10 gigabit in a business environment, business network. Okay, so that was a lot on technology for 10 gig standards. I'm going to go into applications now. How is 10 gig used in the real world, in business networks? First one we'll show here I call 10 gig to the desktop. So this is out at the edge layer of a business network. Maybe it's a small office network, and it's running some specialized applications where the workers, the employees need 10 gigabits to their desktop for one reason or another. Maybe they are doing video editing and they have large files going back and forth from their PCs to the servers in the storage, or medical imaging files, or CAD files. Could be a variety of different applications, but the point here is out at the edge layer we need 10 gig connectivity from the workstations to the servers and the storage. So we use a 10 gig smart switch, showing an 8-port 10G base T smart switch here. So we've got Cat 6A, Cat 7 connecting the workstations to the switch, and then the switch over to the servers and the storage, all happening out on the edge of the network. And note here I show a laptop and a printer that are 1 gig. We can still plug those into this 10G base T smart switch as well. So that's at the edge layer. Here's an example network, maybe a small or medium-sized office network where we're using 10 gig in the distribution layer. So at the edge, we've got gigabit switches, typically going to be 24 and 48 port gigabit switches that are connected out to the employees, the workstations, the IP phones, the printers, and then all of that gigabit traffic gets aggregated by these smart switches with 10 gig uplinks into the distribution layer of the network. And here I'm showing another This one is an SFP+, so this is an optical switch, a smart switch that's taking in these 10 gigabit links from the edge switches and aggregating all that traffic. And of course, if I'm concerned about redundancy, I can add a second switch here in the distribution layer to handle redundancy in case of a failure. And then there's a lot of protocols that I would use. ERPS is Ethernet ring protection switching. Some people just prefer to use spanning tree, etc., to handle the redundancy here. And in the case where I've got a little bit of a larger network, an enterprise or a campus network, and my 10 gig switches in the distribution layer are really getting full of traffic, maybe I would want to use 40 gig uplinks into the core of the network. So here I'm showing some managed layer 3 switches at the distribution layer. Again, they're taking in the 10 gig links from the edge, and they're aggregating all of that traffic and then sending 40 gig uplinks, probably over multi-mode fiber, up into the core of the network. 10 gig also used in the core of the network. Here's sort of a smaller business enterprise type of office network where they're going to use these managed layer 3 10 gig switches in the core. So out at the edge, we've got gigabit with 10 gig uplinks into the distribution layer. Distribution layer takes in 10 gig, it aggregates that traffic, so perhaps these are smart switches, and then we have 10 gig up into the core, and we're using these managed layer 3 switches for redundancy. I have protocols like ERPS or even VRRP, which is Virtual Routing Redundancy Protocol. And in server closets, we talk about top-of-rack switching. Here is a very small office. They have a few servers in a closet, and those servers, the ones on the left, have 10G-base-T copper connections. The ones on the right are optical. They're SFP plus 10 gig connections. Either way, we've got smart switch sitting at the top of the rack that takes in all of that traffic and switches all of that 10 gig traffic. So it's a copper switch on the left side, 10G-base-T. I've got Cat6A or Cat7 connecting them down to the servers. And on the right side, this is SFP plus optical switch. So I've got, perhaps I'm using direct attach copper. And in a larger data center, enterprise campus data center type of application, here I've got more servers, I've got more storage. In this case, perhaps I would use a more sophisticated top of rack switch like the layer 2, layer 3 switch that's shown here. This one is all fiber ports, SFP plus fiber ports. So I would use direct attach to get down to the servers and the storage. Probably other features I'd be concerned about as well here in this type of environment. I may choose to use cut-through switching instead of store and forward. Cut-through is a way to actually get the Ethernet frames in and out of that switch faster, so I minimize delay, I minimize latency. And then there's protocols, data center bridging protocols like the ones shown here, 802.1 QBB, QAZ, QAU. These are basically specialized protocols that you'd find in a switch of this caliber in the event of congestion, to make sure that it's managed properly, the bandwidth is allocated where it needs to go, and there's no data loss. So this is a more sophisticated type of switch that would be used for 10 gigabit switching in top of rack in a data center. Okay, so I went through it pretty fast, but I'm trying to be mindful of time here. The last couple slides I have are some D-Link 10 gig switches. We talked about some of these already in the previous examples. This is D-Link's DXS 3600 series. This is a top-of-the-line layer 2, layer 3 managed aggregation switch. It's available in 2 different flavors with 24 SFP plus 10 gig ports, but also with 8 SFP plus 10 gig ports. Both of these switches have a expansion module that you see on the right side of the switch. And that expansion module is available to add additional ports. So I can add more 10 gig ports or even gigabit ports to the switch, and I'll show that on an upcoming slide. The 3600 has hot swappable power supplies, so dual redundant power supplies, 3 fans that are hot swappable. It supports features like physical stacking, and as I mentioned previously, store and forward or cut-through switching for lower latency in data center type of applications. Lifetime warranty, as is the case with all of our managed switches. These are the expansion modules that plug in, so I can add 8 more 10 gig SFP plus ports. I can add 8 10, 100, 1000 gigabit ports, 4 10G base T ports, or for the uplinks that we talked about on an earlier slide, if I need 40 gigabit uplinks, this expansion module on the upper right side of the slide here has 4 times 40 gig uplink. So that's a lot of bandwidth going up into the core of the network using QSFP plus modules. And then the larger of the two switches supports stacking as well. So there's a module that supports 2 120 gig stacking modules. A lot of bandwidth. The 3600 has a couple different software images. It ships with what we call the standard software image that supports basic layer 2 plus functionality. It can also be upgraded to the enhanced software image. And I'm not going to read all of these protocols to you here, but it's very advanced layer 3 routing, multicasting, and MPLS types of functionality. But now we can certainly step down in caliber and step down in price, and we can get 10 gig switching functionality in smart switches as well. We introduced the 1210 series earlier this year. It's been a very successful product for us, the DXS 1210, available in 10G base T copper as well as SFP plus fiber. The unit on the top, the 12TC, has 8 10G base T copper ports, 2 SFP plus fiber ports, and then ports 11 and 12, or what we call combo ports. They can function either as copper or fiber. And then the 12SC shown on the bottom is 10 fiber ports and 2 combo ports. So the 1210 series is it's what you would expect in a smart switch. It's web smart. It's very affordable, designed for networks, business networks of all sizes. It does support static routing and Ethernet ring protection switching, and all of the essential layer 2 features like VLAN, QoS, spanning tree, IGMP snooping that you would expect in a web smart type of switch. And it also comes with the advanced security features, most notable access control lists, IP MAC port binding, etc. We are announcing in first quarter of next year a new smart switch in our Easy Smart family of switches, the 1100 series. So this is the DXS 1100. So this is even lower cost 10 gig switching, and this one is also 10G base T. The first 8 ports are 10 gig copper, and then ports 9 and 10 are 10 gig SFP plus. So this is not quite as sophisticated as the 1210s. It still has the same essential layer 2 switching features like VLAN and QoS and IGMP snooping, maybe lacking on some of the other more sophisticated features. But this is a very low cost, a very affordable 10 gig switch for networks basically of all size. So look for this coming in early first quarter of next year. And when we're talking about 10 gig, we have many families of gigabit switches. These would be work group type of switches that all have 10 stacking ports or uplink ports. So what I'm showing here, circled in the red ovals, all of these gigabit switches, again, typically 24, 48 port switches, they're all going to have either 2 or 4 10 gig ports that would be used for uplink into the distribution layer of the network, or perhaps used for stacking. And I'll remind you that the DGS 1510-20 is today's giveaway. That is a 16-port gigabit Smart Pro switch, and it also has 2 gigabit SFP and 2 10 gigabit SFP plus ports. So stay tuned for that giveaway coming shortly. In our accessories, we have network adapters. The one on the left is a single SFP plus 10 gig port. The one on the right is dual 10G base T ports. So that's dual 10 gig copper ports. In both cases, the interface is a PCI Express interface. Remind you, some of you may be aware, we are currently running a promotion right now when anybody buys a DXS 1210-12TC, that's the Web Smart 10G base T switch. You qualify for a free DXE 820T, that's the dual port 10G base T NIC card. So that's a pretty neat deal there, and that promotion will go through the end of December. Transceivers I won't spend a lot of time on. We sell a lot of different optics, 100 meg gigabit. In the 10 gigabit I mentioned earlier, we still sell XFPs, and then in the SFP plus space we have multi-mode, long-range multi-mode, and then single mode as well for the 10-kilometer application. And then direct attach copper. These are direct attach copper cables. You recall I mentioned earlier these are used for shorter distances up to 7 meters. They use the SFP plus connections on a switch to a server or to the storage, and they're really a great low-cost way to get 10 gig connectivity without having to spend money on fiber optics and cable. Okay, so I ran a little bit long, but that's basically the presentation. Summarize what we talked about. 10 gig market, it's growing in terms of revenue. In fact, worldwide, 10 gig is overtaking gigabit this year in the switching revenue market. But on the other hand, costs are continuing to go down. Costs are shrinking, and we saw that as well. We saw 3 or 4 years ago, on average, 10 gig was selling at $300, $350 per port, and today we're approaching that $100 per port. And in fact, with the smart switches that I showed earlier, we've eclipsed that already in a big way, well under $100 per port when we're looking at 10 gig smart switches. 10 gig not just for data centers anymore, low-cost smart switches I mentioned, optics pricing on multi-mode and single-mode transceivers continues to come down in the industry. 10G base T with the new advances in silicon, 10G base T shipping more and more every month, certainly ready for prime time. So 10 gig Ethernet now can be used pretty much anywhere in a business network. At the edge for specialized applications where we need 10 gig to the desktop, in the distribution layer, aggregating 10 gig links coming from the edge, or in the core of the network. 10 gig Ethernet, basically affordable for networks of all sizes. So again, I ran a little bit long. Sorry about that, but thank you for your patience, and that's what I got.
Yeah, thanks, Steve. That's great information. We have some questions that came in, so we'll let Steve take a little breath. But if you have any questions, now would be a great time to send them in. Just a reminder that we are recording this webinar, and it will be available tomorrow, and the link to the recording will be included in a follow-up email, so take a look out for that. And then we'll also have the slides available. So if you're interested in the slide deck, you can email me or put a comment in the question and answer panel, and I'll follow up with you tomorrow to get that the slide deck to you. So let's choose our winners for the product. We're giving away 2 DGS 1510-20 switches, which is a 20-port gigabit stackable Smart Pro switch. So our winners for today are Larry C. from North Carolina and James C. from California. So again, Larry and James, one from North Carolina, one from California. We will reach out to you guys after the webinar and figure out how to get those products to you. But thank you everyone again for attending, and I will hand it back over to Steve to get to Q&A. And if we don't get to everything, we'll definitely follow up with you, so don't worry about that.
Yeah, I show about 6 minutes till the top of the hour, so I'll go 6 minutes, but in the interest of time, I will maybe not get to all the questions, but we can certainly reach out to you individually and address anything else that doesn't get addressed today. There's a couple questions here on a topic that I purposely didn't talk about today, but I can address it just quickly now. It has to do with a new high-speed Ethernet standard that's being worked on by the IEEE. Before the IEEE started working on it, there were a couple different proprietary organizations that were looking at it. One called it N-base-T. Another organization was looking at MG-base-T. As the IEEE gets started working on this, I believe they're going to call it 802.3 BZ, lowercase b, lowercase z. And basically what it is 2.5 gigabits and 5 gigabits over copper, so over Cat 5e and Cat 6 copper. So remember we talked about 10G base T requiring Cat 6a. It's full 10 gigabits, but it needs Cat 6a or better. There's a need in the industry today, especially driven by access points. If you're familiar with the 802.11 AC wireless standard, specifically Wave 2, these are new APs that are going to be coming out that can support pretty high speeds, upwards of 4 or even 5 gigabits. So if I've got an access point that can support 4 or 5 gigabits and I'm plugging it into a gigabit wired connection, I've automatically given myself a bottleneck here. Now I could do things like aggregation. I could do link aggregation and get a couple gigabits of backhaul on that access point. But the industry has recognized that we need a new speed. 2.5 is a sweet spot, 5 gigabits is a sweet spot. And it's better to do this if we can avoid having to recable the workplace with Cat 6a, Cat 7 and use the existing Cat 5e and Cat 6 that's in place. So that's where this standard is coming from, and we're hearing more and more about it, especially as the IEEE continues to work on it. So again, it's coming. When it comes, you can expect to see Ethernet switches supporting 2.5 and 5 gigabit, so it's like a sweet spot almost between 1 and 10 gigabit. You'll see access points supporting the speeds as well. D-Link's position on this is we're working with our chip vendors, with the silicon vendors who are sitting on these standards boards, and as they develop the silicon, the PHYs, and the chips that support these new speeds and standards, we will of course be supporting products that incorporate these. Today there are some vendors that offer proprietary solutions, but it's expensive. My understanding is in a lot of cases they're taking 10G base T technology and just throttling it back to 2.5 or 5 gigs, so you still bear the cost of 10G base T, and there would be interoperability issues as well. So again, stay tuned as the new standard continues to evolve. I think they're looking at ratification by end of next year, September-ish, I think, of 2016. So as we get into 2016, you'll be hearing more about 2.5 and 5 gig switches from D-Link. Looking at some of the questions here that came through. Can you create link aggregation on these switches, essentially creating higher bandwidth per link? I think we're talking with gigabit, certainly we can. With 10 gigabit, I'm not sure. I have to look into that. How far out do you see consumer 10 gig switches? I'm not sure, to be honest. That's a pretty good question. It's something that I think about as well, as the prices of 10 gig continue to fall. When will we have consumer 10 gig switches? Maybe what will happen in the consumer space first is the 2.5 and the 5 gig standards that I talked about. I know that in some cases, like with these gaming, what do they call these gaming conventions, where people get together and have LAN parties. I know sometimes they use 10 gig for that, but actually to have consumer products supporting 10 gig, 10G base T, that's probably still pretty far out. We are starting to use more and more fiber for our clients. I'm not sure if that's a question. Internal bandwidth. Why would we use direct attach cables compared to Cat 6? You wouldn't. Direct attach, I think, was something that was a little bit more popular before 10G base T came down in price, came down in power consumption and heat generation. But as far as which is used today, in a way, it's a function of what's on your switch, what's on your server, and on your storage. If you have servers and storage today that have SFP plus cages, 10 gig SFP plus cages, then direct attach, of course, would be more cost effective to use. If you have a choice, I personally like 10G base T. I think it provides a little bit more flexibility, and it's a lot easier. You can terminate your own cables, and it's a more familiar form factor with the RJ45 connectors. Do you have a pricing and configuration tool available to us? Certainly we do. I think on our partner portal we have things like the, what do we call the
product selector? The
product selector that allows somebody to go in and choose what type of switch they want. But even on our website, I think the product selector is on there as well. So you choose what ports you want. Do I want 10 gig copper, 10 gig fiber? So look on our website for something called the product selector, and that at a minimum helps with configuration and finding the right switch.
And then he's also asking about pricing. So Seth, we'll reach out to you, the sales team will reach out to you on pricing information as well. And it's about 12 o'clock. Can we wrap it up?
Yeah, there's a couple other questions here, but we can reach out privately to these individuals and make sure that the questions get addressed.
Okay, great. Thanks again, Steve, for all the information. It was really good, and thank you everyone for attending. We really appreciate that you're attending the webinar. Congratulations to our product winners again. We'll reach out to you to figure out how to get the products to you. And then with that, we'll wrap it up and just say happy holidays to everyone, and hope to see you on another webinar in 2016. That's it. Thank you.
Yes, thank you.